Hi everyone. Have we got any F1 fans in the audience today? Lando fans? Max fans? Oh, look at that. Hamilton fans? I won't go through the whole list. Hi everyone, my name's Nick Morgan. I'm a solutions architect here at AWS. On stage today with me, I'm going to be joined by Jamie Mullen, a specialist SA for Edge Services. And I'm delighted also to welcome Dave King, Head of Digital Technology at Formula One. But before we sort of get into the meat of the presentation, just want to introduce Formula One really and mention that they're celebrating 75 years of this fast-paced sport. And it being truly a sort of a global sport, the season runs for 24 races in 21 countries and has become what we think is one of the greatest spectacles on earth. With a cumulative audience of 1.6 billion people and over 825 million fans worldwide, the sheer logistics and infrastructure is truly mind-blowing, really. If you've ever been to an F1 race and seen what goes on, it's amazing. But today we're going to tell you about a couple of examples of how AWS and Formula One deliver not only world-class operations, but also deliver the racing action directly to fans through the innovative world of multi-screen TV. AWS started working with Formula One back in 2018, became a global sponsor for the 29 season. The partnership was renewed in November 2022, and we currently operate at the top tier of partnerships within Formula One. AWS works with many other sports leagues, so things like the NFL, PGA, Bundesliga. But the unique thing we saw about F1 really is around, and at the heart of it is the data, and it's been data's been the heart of it since the 1950s. So with Formula One, we sort of focus on deep collaboration in three main pillars: transformation of data into racing intelligence, fan experience enhancement, and also technical transformation through the joint technology funds that we run with F1. Just to pull out a couple of examples along the journey together. So back in late 2019, F1 and AWS completed the CFD project to design the 2021 car, reintroducing the ground effect era to Formula One. In 2021, F1 Insight, powered by AWS, was born. The Insight graphics are displayed during the race and provide key data points, allowing fans access to not only entertaining events during the race, but also key metrics and predictive analytics. We expanded the partnership in 2022 and started work on the Fan 360 program. In terms of Gen AI, I'm sure the fans out there will know that we produced the trophies for the Canadian Grand Prix in 2024. And then more recently, early 2025, saw the launch of F1 TV Premium, a multi-screen over-the-top platform. Also in this year, we collaborated on the launch of root cause analysis. Later, we'll tell you a little bit more about these projects. So as you can imagine, F1 is a really data-heavy sport, and Formula One kind of represents what we think is one of the most data-intensive sports in the world. Each F1 car generates over 1 million data points per second, and during a typical race weekend, we process more than 5 million data points across all cars. This is roughly equivalent to streaming 1,500 high-definition movies simultaneously. The mass of the data delivers insight, innovation, and we fundamentally feel we've transformed the way how teams compete and how fans experience the sport. So how is the data captured? To illustrate this, we're going to use the circuit in Italy, the Imola circuit in Italy. And if you look at the topology of the track, about every 200 meters or so, there are induction loops around the circuit, and these make up the segments that ultimately make up the sectors that the timing's taken from. In addition to this, there are radio towers. These towers receive the data from the car. That data includes live telemetry data and also the onboard video. If we move over towards what's known as the Event Technical Center, this is connected to the circuit via high-speed optical links. And think of the ETC as like a mini data center, but it also houses a video production gallery. And this building's portable and follows the racing season around the world. If we then take the next step on, we go towards the Media and Technology Center, which is based in Biggin Hill in Kent. Again, linked through high-speed fiber optic link. But in this building, there's a full broadcast suite, including a video production gallery, there's 3 studios, and there's also space to accommodate commentators and also events. The M&TC, as it's known, also houses other departments that take care of things like IT, so on-prem and cloud, racing systems, track systems, and engineering. So how does that connect to AWS? So the M&TC connects to AWS via Direct Connect, and these links are used to send a subset of the telemetry data and the finished video feeds. These feeds include the World International feed, all onboard cameras, and some pre-canned graphics feeds. This is where we ingest the video content for F1 TV. The telemetry feeds also include sanctioned data points that we use for processing predictions. So now let's take a look at what goes on in AWS. So we use a mixture of machine learning and mathematical models for F1 insights. Amazon SageMaker is really the inference engine that sits behind this. And each model has been designed and trained to meet the needs of the F1 broadcast. The ML models are also retrained between race weekends to improve accuracy and keep pace with the drivers and the way the season's developing. So all models are stored in S3, ready for when the data arrives, but that's not the only use of S3 for Formula One. As I mentioned before, the Customer 360 data lake sits within that. And this is a single source of truth for fan profiles and interaction data that's generated across the digital estates, so things like F1.com, F1 TV, and other channels. S3, Amazon S3 is also used for the video archive, and there's over 7 petabytes of historical data that sits within that archive. So if we take a look at the inference pipeline, this is where the data meets the model and produces new insights. In reality, the data is sent via Amazon API Gateway. Under the covers, the code is executed with AWS Lambda jobs, and the results are stored in DynamoDB. The code that interacts with the ML models ultimately returns the results via API Gateway to the Media and Technology Center. Amazon DynamoDB is a NoSQL key value store, as I'm sure you're aware, but it holds the results of the analysis and all of the model training. So this allows F1 to further enhance the model's accuracy and play back the data to support other simulation activities. Amazon CloudWatch is used to store log files for operational needs. And interestingly, the data that Amazon CloudWatch is driving at the core of these insights helps F1 keep track of how these discrete systems are performing across the organization. Having processed the results are now available to the video production teams. This insight data is sent out over various departments within the M&TC. So the graphics department, for example, prepare the graphics and queue them up ready for the production of the World International feed. And then the director can select which insights help tell the story on the day, if you like. So bear in mind, the end-to-end processing happens in under a second. So from the car to the track, through into the ETC, M&TC, into AWS, processed, and then back to the M&TC, where the graphics are produced ready for the broadcast. So it's really important for this data to be accurate and really sort of help tell the story of the race on the day. So this leaves us with a business challenge, as it always does. This is a high-stakes environment where everything must work in unison to deliver the race in action to the fans, and given the interdependency and complexities of these systems, being able to fault find at pace is critical for F1's operations. So let's introduce root cause analysis. RCA allows F1 to quickly fault find and gain critical insights from CloudWatch logs from the applications that underpin each race. The project was initiated through the leadership of Ryan Kirk, head of cloud and DevOps at Formula One. The goal here, to harness the power of generative AI to deliver a step change in intelligent root cause analysis. So let's take a look how RCA works. Utilizing a multi-agent orchestration with supervisor and specialist agents, F1 were able to onboard over 500 applications into this chatbot-based system. Keeping a knowledge base of each application and centralizing all logs into Amazon CloudWatch, we implemented a solution that can perform automated analysis of specific applications to discover faults and report those faults back. With results evaluated and summarized, support tickets created, and the train of thought of the LLM stored for further and later analysis, this system has vastly improved the discovery and resolution of issues. Built around Amazon Bedrock and other AWS services that collate and process the data. Press the button. The vast majority of applications run in Kubernetes, and these applications can auto-enroll with the RCA tool, identifying their core components. Bedrock takes over the agentic orchestration, calling supervisor specialists to process tens of thousands of rows of log data to find issues and anomalies. So let's take a closer look at a query. From the chatbot, a human support agent can ask it questions. In this case, we are asking about a database that supports the FOM API, or the Formula One Management API. The first thing that happens is the application configuration is pulled from a lookup table. Metadata about the application's infrastructure and CloudWatch log locations are pulled. This information forms part of the initial LLM query, and a suitable prompt is sent to a specialist support agent. Each specialist agent is configured to support certain types of queries, such as interact with CloudWatch, test database connections, and trawl through things like network and firewall logs for analysis. Results from each specialist agent are sent back to the supervisor for analysis and processing, really to work out what the big picture is essentially with the problem. In this example, Amazon CloudWatch database connection and network logs have been queried, and the following issues have been identified. There's a configuration error in Kinesis, there's a broken database connection, and also an overloaded network device. The support agent then makes a determination, again, based on the tuned prompts, and creates a summary of its findings. At this point, given that there are errors, a support ticket is generated detailing what's been discovered. The specialist supervisor then returns its findings to the orchestration layer, again summarizing the issue and providing extra information about the ticket and root cause. Finally, the UI receives the findings and relays this back to the human support agent. The chat agent keeps a history of the chat for future reference and analysis of the chain of thought. So in summary, using a multi-agent approach, F1 have been able to realize a step change in RCA productivity with a 95% reduction in full ticket resolution time and the initial triage down from 45 minutes to just 4. AI can programmatically trawl through log files at a machine-level pace, finding issues quickly and efficiently. Automated ticketing puts issues into the system quickly, alerting support teams across the organization. So harnessing the power of this orchestration, domain-level specialist agents, and direct access to CloudWatch centralized logs, and being able to describe your applications in terms of metadata objects along with carefully crafted prompts, F1 have realized a step change in analysis for mission-critical applications. So if you'd like to take a look at our prototyping blog, we've also recently had a blog published on Wired as well. There's some QR codes at the end of the presentation. And I'd just like to thank you for your time, and I'm going to pass the baton over to Dave King, Head of Digital Technology at Formula One.
This season, you're in the race.
At last.
Fully immersed in every Grand Prix, live. Watch what matters most. Create your custom race view from multiple feeds.
Look what he's done with the opportunity.
Miss nothing with pristine 4K. See what every team sees in every moment.
This is an inexplicable Grand Prix.
And analyze what really happened, why, and when.
Because these are cars that have 1,000 horsepower.
Stream all this and more on up to 6 devices.
Wow, wow, wow.
A new way to see a new era.
He's done it. He's won it. He's done it, mate.
Hello everyone, and thank you Nick for the intro. I asked for a little hype video. Find it's easier to start that way. So I'm David King. I'm Head of Digital Technology at Formula One. My team and I have the privilege of designing, building, and delivering change across our consumer-facing digital properties. Some of them you can see on the screen in front of you. You've seen a little trailer for F1 TV Premium. That's what we're going to talk about in more depth, but we're going to get there in a minute. So Formula One, we have responsibility for our F1 web and app, completely relaunched in 2025, bringing vertical video, completely restructured site, live blogs during race day, short-form video, vertical video, written and editorial content. It's the home of everything F1 for us. F1 Live Timing, which is what you see here on the mobile device, is the service we use. All the data Nick talked about collecting from the cars, the telemetry, the positioning, the sector times, the mini-sector times, the deltas between the drivers, all accessible as a second screen experience, whether you're consuming the broadcast on F1 TV, through Sky Sports UK, through ESPN, through Viaplay, whoever it might be. That's your second screen experience. You can see what's happening even if the broadcast isn't actively covering it. F1 Fantasy, 2 games here. One traditional fantasy game, select your driver, select your team, select your boost for a given race, who's going to finish in the top 3. So compete against your team, your colleagues, your friends in leagues, and then the F1 Predict game, a little more ad hoc, 10 questions for each event, launches typically on a Wednesday before an event, who's going to be on the podium, who's going to gain the most positions in the race, all of that kind of good stuff. Quite good fun. I'm not very good at the first one, not bad at the second one, and it's easier to dip in and dip out. Then F1 TV, the thing we're going to talk about in more detail. F1 TV is a product that we launched back in 2018. It's our own internal OTT platform. It's available in 132 countries. Some, it's there on its own. In others, it sits alongside our traditional broadcasters. We work across all mobile devices, tablets, big screen devices, and on web. And that platform's been there, as I say, since 2018. We've always had access to all 20 cars on the grid, so all the onboard cameras, 2 international feeds, and 2 data channels that kind of support the viewing experience. Within that platform, there are 2 subscription tiers, a replay tier or a full event replay and VOD content, and then F1 TV Pro, which has always been our live experience. The problem with that live experience was you've got all of those feeds that you can view, but we only let you switch between them, so you could watch one of them at a time. So you could switch to watch Max and take that P2 in last weekend's race off the grid, but you couldn't see what else was going on. So what we set out to do was to build F1 TV Premium, and I should have clicked that twice earlier. So what is F1 TV Premium? In fact, does anyone use F1 TV, first off? And are you a premium subscriber? Okay, a few. Enjoy it? Useful? You're worried about Disney? Don't worry about Disney. So what is F1 TV Premium? F1 TV Premium is something we've been working on for about 18 months, 2 years, prior to its launch at the start of this year. We wanted to bring a really compelling multi-angle experience to our sport. We're in a pretty unique position to have access to all of the live feeds, all of the time, for every event. And it's different to multi-view for a single sport like football or American football, where you can watch different games and it doesn't matter that things are slightly out of sync. So one of the key challenges we were trying to address here was creating that multi-view experience, but ensuring that everything was in sync. And sync is a thing that you'll hear me talk about again, and Jamie when he comes on to talk about the media services element of this. But there were a few more things that we added just to make this a little more complicated. So historically, F1 TV has carried HD feeds in SDR at 50 frames a second. The last kind of jump we made of the kind we made here was when we moved from 25 to 50 frames a second 3 or 4 years ago. But we set ourselves quite an aggressive challenge to go from HD HDR to full UHD HDR. And that, whilst that had been around in F1 and through traditional broadcast before, anyone who works with media services and distribution and OTT knows that that step from HD to UHD is quite a large one. So that's step one. We also did the same for the onboard cameras, moving them up to HD HDR, supporting multi-view, but we wanted to make sure we got that spread of devices as wide as we could with that same compelling experience. And then the less interesting bit, but allowing that playback on multiple devices, so creating your multi-view on 5 or 6 devices at the same time. So I'm going to play this video, and I'm going to talk you through what's happening, but this is on a tablet device showing multi-view in action. For those of you who haven't seen it, it puts in context a little more what we're going to talk through. So this is coming up to race start. Drivers have just finished the formation lap, and what you can see here is the international feed in the main box. And down the right-hand side, a full 22, 23 tiles of video that are available to the fan to select. We've brought one of them on here. We've brought Lando's onboard camera on. I think he's in P2, P3. And international feed is still continuing. Some drivers disappearing down the pit lane, someone must have changed their engine or power unit. And what we were trying to get to here, and this was the nervous bit, is when those lights go out, everything moves in sync. Because if it doesn't, it's a bit rubbish. And it gives away the story. You kind of eyes caught on one thing, you're misled by something else. So we've pulled up here 3 different feeds, the international feed, the onboard camera, and the driver tracker, all of which should move at roughly the same time. So 5 lights, and out we go. And the international feed, the onboard camera, and the driver tracker all move at the same time. This isn't just a gimmick. This isn't just a thing that we built for this presentation. You can go back to any full event replay on F1 TV in this past season and go to that lights out scene and pull up your view and see that we did what we said we were going to do. So whilst we've got all of this video, we also have all of the commentary, all of the onboard camera audio, all of the subtitles. So it doesn't matter whether you're watching an onboard camera that you want to listen to. You might be interested in listening to Max's comms with his engineer. You can switch that on. You don't have to be watching Max's onboard camera. What we did constrain was the layouts. It's probably the one kind of compromise we made. We could have been fully flexible, but we honed this down to give what we think is the most flexible and still compelling experience with the options that are available, rather than a complete free-for-all of moving video all over the place and resizing. So this is what we think works well. The swap of video is pretty slick as well. I didn't actually talk about that when it happened, but it works really well. So we're going to start talking about that video workflow, because there are 3 significant pieces that needed to come together in tandem to make this work really well. The first bit Nick talked about in terms of capture at the circuit. So Nick mentioned that all the video for the onboard cameras, so cars traveling at 200 miles an hour down a straight, is radio frequency transferred off the cars, round a fiber network at the circuit, and back to our event technical center. So that's one element of what we carry on F1 TV. We then have 25 to 30 track cameras around the circuit, also connected to that fiber network, also back to the ETC at the circuit. Great. We then ship all that back to our M&TC, our Media and Technology Center, back in Biggin Hill. And that's where the final cut, the production element of F1 TV, but also the broadcast happens. And then we just push it into the cloud, and magic happens. But it's not quite as simple as that, because there are 3 or 4 different classes of video. They all follow slightly different paths. The onboard cameras are relatively raw and untouched when they arrive with us to be processed and ready to be distributed to the cloud, so they followed one path. You then have all of those track cameras, all of the radio frequency cameras from camera operators up and down the pit lane, getting all those great shots, be it of the pit wall, be it of the driver doing a tire change. Hopefully not the driver doing the tire change, that would be problematic. But they all arrive with us at slightly different points in time. And if we go back to one of the things that we were trying to achieve here was making it really, really great experience, everything has got to be in sync. So our first job, before we even get to AWS, is that alignment of feeds within our Media and Technology Center and insertion of a time code. Simply a time reference that says, this feed, and this feed all share the same time code. So before we pass things into AWS, we get those time codes in order. Now, before I hand over to Jamie, there are some architectural principles that apply more to the media services element of this solution that we wanted to try and adhere to. This wasn't our first rodeo. Our target, whilst bringing in UHD, HDR, was that we would have a single media live ABR encoding ladder. We didn't want multiple outputs here. We didn't want multiple instances of media live trying to do the same thing. We also wanted to continue to support our existing F1 TV Pro experience, that single view experience, because that's a large part of our fan base already, and premium and multi-view isn't for everyone, slightly different price point, also device compatibility. So there were reasons that we wanted to protect that experience, but also protect ourselves operationally to make sure that we could provide the best experience for our fans. In terms of multi-view, we wanted it to be as flexible as possible on the client side. So the power was in the fan's hand. I said that we constrained it, but I don't think we constrained it that much. We didn't want to be tied to the video stack on operating systems. That was always going to be a problem. iOS 26, Android 14. You were constantly fighting a battle. And for the level of control that we need to create that in-player experience, it had to be a player that was built from the ground up. The same applies in terms of giving the broad device support. And then we talked about synchronization. We'll talk about it again, but we got everything in sync at the start of this. As we pass it into Media Connect and into the media services pipeline, we need to maintain that right through the media services pipeline and through the distribution to a client device. So with that, I'm going to hand over to Jamie Mullen, Senior Specialist Solution Architect in the media space, who can talk you through in more detail.
Thank you. So hey everyone, my name is Jamie Mullen, obviously. I'm a Specialist Solutions Architect here at AWS. I've got the privilege of kind of deep diving the AWS element of media services that help bring the streaming part of F1 TV Premium to life. So we're going to focus on these 3 challenges. We're thinking about, how do we make sure these feeds are aligned, like Dave described? We're then going to think about how are these streams really encoded and how are they packaged? And then finally, we're going to dive into, how does my encode change to deliver a multi-view experience? And we'll actually look at some of the what we see in the industry, to enable multi-view. But let's focus with the big one first. Let's focus on channel and content synchronization. So if you're not familiar with AWS Element and Media Services, this is what we kind of see from a typical workflow. So we have AWS Element and Media Connect, which is our secure and reliable transport service for live video. We then have that as an input into AWS Element and Media Live, which is our cloud-based broadcast-grade video processing service. We then have AWS Element and Media Package, which is our just-in-time packaging and origination service, where you can implement DVR-like experiences and also things like DRM. And finally, we've got Amazon CloudFront, which is our content delivery network, which you can distribute via. And then based on your viewer or your client, you can obviously pull what manifests and stream that you want. But customers like Formula One operate with more resiliency than just one region, especially for those big events. But these multi-region architectures actually have the same synchronization challenges for failover. So I'm going to show you what this looks like for a failover example before kind of relating what this actually looks like for F1. So we've got the same architecture as before, but we're actually split across two regions. So we have region 1 and region 2. The only addition here is that we've got AWS Elemental Live, which is our on-prem encoding appliance, which in our case is doing the contribution encoding. So what happens if something goes wrong for region 1? The viewers and the clients are currently streaming from region 1, but what happens in this case? Well, clients might actually start seeing black frames, and hopefully, you know, in the media and distribution world, you've got an eyes on glass operations team, and they're looking for issues, and they eventually spot this issue and want to do that trigger to fail over to region 2. However, remember, if this is a real team, there might be some delay in spotting this issue, and also there might be some time delay in actually carrying out that failover. So once that failover is complete, the clients can then go get a new URL for the second region via a URL vending service of some sort, and then they can start streaming again. But when clients rejoin that stream on region 2, there might be some challenges around, you know, is the two feeds aligned between region 1 and region 2? Are they going to have to go back into the stream and scrub backwards to find where they were before? So the key challenge here, and what we're going to kind of think about in this sense, is how do you keep things in sync, and how do you do this automatically? Something called timecode, which Dave mentioned, is part of that answer. So if you don't know, timecode is a time reference embedded in each video frame. Timecode can be super, super important in the broadcast and distribution world. How we're going to look at it today is we want to use it for synchronization. So we want our downstream components to use this timecode to help us solve this problem. So timecode's part of the answer. How does it apply to a failover scenario? Well, we have a couple of features that we're going to run through quickly just to show you what that might look like. One of which is called seamless cross-region failover. And what we mean by seamless is that we want frame-accurate alignment across all your origins. So in our case, region 1 and region 2. In the manual failover example before, this potentially wasn't seamless, nor was it automatic. So we've got the same architecture, but this time we're going to start with the time code, and that's going to be on the on-prem Elemental Live device or appliance. So that common time code is applied to that contribution source, and so that both regions receive that aligned contribution feed. We then have Media Live, which is configured with epoch locking, and basically it uses the embedded time code from that contribution feed, and then the timing source is set as the input clock. So Media Live outputs via CMAF ingest into media package, and when you combine CMAF ingest and epoch locking, what you actually get is a regular segmentation cadence based on that epoch time. And media package can also use this as a stateless synchronization to predictably package the output content. So what happens if something does fundamentally go wrong with the video, whether it's slate inputs, incomplete manifest, maybe even a missing DRM key? Well, media package has the ability to 404 its endpoint. And finally, the missing piece of this puzzle is CloudFront. And CloudFront, you can use something called origin groups, where you specify a primary and a secondary. So in our case, region 1 is the primary, and region 2 is that secondary. The other important part of this is that it's configured, or you can set something called a failover criteria, and that is based on those HTTP status codes. So when media package does 404 that endpoint, that request will automatically get sent to the second region via the secondary. But what if it isn't such a fundamental issue with the video? Like, what if it's just one issue where you've got an intermittent black frames or frozen frames going to that one region? Like, how do you handle that? Well, building on the previous architecture, we have something called media quality aware resiliency to help solve this. So on AWS Elemental Media Live, we generate something called an MQCS score for each segment, and MQCS stands for Media Quality Confidence Score. And it's based on multiple input parameters, such as input source loss, black frame detection, or even frozen frame detection. And that score is between 0 and 100, and obviously 100 indicates the best quality. Media Package then provides an in-region quality-based failover with this. So it can basically select the segment that has that higher score. But not only that, it can actually signal it on the egress too. And that is signaled via CMSD. And finally, the missing piece of this as well is previously we was using origin groups, but we were using the default settings. You can actually use quality-based origin selection instead of that default in the last architecture. And basically the way it works is there's a get and a head request sent to each region, and then it basically selects that segment that is going to provide that better user experience to that viewer. So we've kind of looked at a failover example, but how does that actually relate back to F1 and F1 TV Premium, especially around the epoch locking and that predictable packaging element? They want to achieve the same stream alignment, but across multiple channels, not just one channel in multiple regions. So if you've not seen the AWS Elemental Media Live console settings before, this is how you can configure this for epoch locking. So as Dave said, they provide 24 video feeds for a live session for viewers, and that common timecode is applied across all those feeds. Media Live is then configured with the output timing source with the input clock, the output locking mode with epoch locking, and then finally the timecode source configured as embedded. Another really important aspect to this is encode configuration. So F1 also applies a really consistent encode parameters for things like frames per second, GOP size, and disables things like scene change detection to keep all those channels encoded and packaged consistently. The end result is this. Not only can you get timecode alignment in a single channel, you can actually achieve this across multiple channels. So you can see F1 Live in the bottom left-hand corner. You've got an onboard camera of Lando Norris on the MP2, I think. And then you've got Max, who is P1. But you can see the timecode is all configured similarly. So in summary, with timecode, Media Live, and Media Package, you can actually achieve this server-side channel synchronization. So that's the first tick in the box, like they were saying. But traditionally, when you deliver content to viewers, that might only be one show or program at a time. When you want to consume content like Formula One, you might want to consume more of those feeds at the same time. So I'm going to quickly cover some of the industry themes on how you could implement multi-view and how it actually changes your video encode workflow. The first one is server-side multi-view. This is where you have a feed pre-composed upstream, and the client device can just simply consume it like any other OTT feed. However, this presents a challenge. There's no real flexibility, right? If you want more flexibility on the clients, you're going to have to produce more feeds to do this. So taking F1, for example, they do 24 video feeds that you can consume in F1 TV Premium. If you have that 2x2 grid layout like you see on the screen now, that's over 10,000 new streams required to cover every combination. However, there's no downstream synchronization to handle because it's all done further upstream in your video workflow. The only thing you kind of need to think about is you've got those new streams, you might have to change them a little bit for basically your viewer experience and just look at how that looks on a device. The second one is multiplayer multi-view. This is where you have multiple streams available to be consumed, and a user can consume one or can decide to consume multiple streams at the same time. With more than one feed, the device has to have multiple players, right, to play back these channels. And this can be potentially resource heavy. as all the players are kind of sharing that device's underlying hardware. The main challenges on this approach really is how are all the players aware of each other? How do you keep the feeds in sync? And especially around synchronized actions, like if you want to pause, play, scrub forwards and backwards, how do you achieve it all on the same, at the same time across all of them? And finally, how do you provide wide device coverage? i.e., do you have to implement this on many different operating systems to basically get the same experience across multiple devices? However, what changes in your encode profile? Well, everything we discussed around channel synchronization could be a way of trying to solve this, or help with the timing problems. And technically, you can use your existing encode profiles, right? There's no major changes there. You just might have to move to epoch locking with Media Live and Media Package. And then finally, the last one is single-player multi-view with HEVC tiled encoding. Advanced spoiler, this is actually how Formula One decided to implement multi-view. So with tiled encoding settings configured on Media Live can generate a series of independently encoded tiles, which the player and the decoder can use to decode any combination of tile across any bit rate and resolution, displaying what makes sense for that device or what a user has got configured. The player itself has the technology and the implementation to use those tiles from the HEVC segments and merge them together before going via a single decoder. So in this case, we've got we're pulling basically the middle resolution or the middle rendition, and that's being pushed through that single decoder. So how would this change your encode profile? Well, first off, you'd have to start delivering HEVC. Next, you'd have to also start to configure your HEVC tiled encoding settings in Media Live. But equally, you want to also enable epoch locking and all those timing considerations that we spoke about on Media Live and Media Package. Tile configuration is based on multiple parameters. It could be based on a tree block size, and a tile width and height might be based on the resolutions or renditions in your bitrate ladder. But for this example, we're going to keep it really simple, and we're going to say our tile size is roughly the size of rendition 1. So we've got a 1x1 grid on rendition 1. We've then got that same tile size. So we've got 2x2 on rendition 2. And then on rendition 3, we'll continue to use that same tile size, but we've got 9 tiles there, so we've got 3x3. Now this is really important. You need to apply that common tile size across all your renditions so that it can actually be used by the player. So what does it look like in Media Live config? Where you've got that height, width, you've got tile padding, you've got some motion vector config to be disabled, and finally you've got that tree block size setting. So in summary, this is how the streaming part of F1 TV Premium is delivered. We have an aligned timecode from source. We have epoch locking in Media Live with that consistent encode configuration for GOP size and frames per second, and that's used across all the streams. Media Live then uses HEVC tiled encoding. Media Live outputs to Media Package via CMAF ingest to allow Media Package to do that predictable packaging of its output. And then it's available for consumption and distribution via Amazon CloudFront. Then on the player side, the player can then pull those HEVC feeds to decode segments and tiles to how a user has configured on their multi-view setup for that F1 session. So for this one, we're pulling the top bitrate of the car. We're then looking at the middle for the cockpit view, and then finally the lowest rendition for that track view. And then you can see the viewer configured experience in that bottom right corner. So Dave, F1 TV Premium went live at the start of this season, right? It was Australia. It was overnight. How did that launch go? How did you? I'm really keen to kind of understand.
You were there. Yeah, I mean, we'd been working this for a year and more.
Yep.
Before Australia this year. Start of season is always quite twitchy anyway, doing a fairly significant product launch. Yeah, it was touch and go. But we had set ourselves up in Biggin Hill, so where our media and technology center is. We had our AWS colleagues, our development partners colleagues, and the player organization were there as well to really team together. Nothing quite like working Australia hours in the UK when you're launching a new set of features. We were pretty confident, but when you sold something in the weeks and months leading up to that you've proven in testing, but not on thousands and thousands of devices around the world, it's always a little nervy. But come the end of practice one, I think we were all kind of pinching ourselves and going, cool. This is going pretty well. It's probably the smoothest product launch I've been involved in all my career.
Cool. So obviously the session today was really focused on that video synchronization. We indexed heavily on how you did it with Element and Media Live and Media Package, but it wasn't just that part, right? There was a wider piece of work to do both ends to give that end-to-end video synchronization.
Yeah, it's those three parts. The media services bit sits right in the middle, and everything you've articulated is exactly how that is managed. But there's a whole piece of work that we had to undertake before the start of this year within our broadcasting domain, because that was critical. That was within our gift to get feeds aligned before they went into AWS. That involved a fairly significant amount of effort from non-digital and into broadcast engineering. That first event, we have about a 250 millisecond round trip latency from our MNTC in Biggin Hill over our kind of diverse fiber paths to the circuit. We were there in our high-speed track test, so a non-televised session before the weekend begins, where we put safety and medical cars around the circuit and do a full system test. And we were there looking at the live video output, making sure that things were visually aligned, like trying to find markers on the circuit from different camera angles to get that certainty that what we configured in each of the delays across all of the 24 feeds was good. The other variable I didn't actually touch on, our international feed, we delay within the building because we take international commentary contribution from broadcasters. So we have to actually let the commentators see the feed before that we can take it back and embed it and align it in our feed, as well as our own F1 TV production feed, which is produced in-house, both commentary at the circuit, presenter hits in the pit lane, wraparound content, all of this stuff at different times. It was pretty touch and go, but we went into that first session pretty confident and came out of it really confident and talking about what could we do next, what was the next experiment or change that we wanted to undertake.
I guess we're already at the end of the season, right? It's flown by, and the way that the championships kind of rolled out, you've got that three-way fight, right, between Max, Oscar, and Lando. Like the video sync part is going to be really interesting, right? To watch that unfold.
Yeah, the video sync was a thing that we were concerned about would drift or change throughout the season. We haven't touched it since probably race 2, race 3, and that was like real fine-tuning of literally 1 or 2 frames. In fact, I think the recording I showed was from race 1, and if you look very closely, Lando's camera's out by about 2 frames versus the international feed. I'll take that. 2/50ths of a second. But yeah, this is prime. This is why we built it, to get that big screen experience from multiple angles at the same time. As I say, it's really easy to do this for, I say easy, and it's not, but it's easier to do this for a multi-event sport where time doesn't matter, and it doesn't matter that Messi scored 4 seconds before someone else scored in a different match. It's like this is all happening at the same time, and when the lights go out on Sunday in Abu Dhabi, I'm going to look at the analytics and metrics and see how many people have got the international feed, Max, Lando, and Oscar as their multi-view to see what happens going into turn 1.
Are you gonna have that set up, or are you gonna have a little bit further back just so that you can actually see what's happening?
No. I'll fortunately be in the position in the weekend, probably being in the MNTC on Sunday for lights out. So I'll have a production gallery in front of me as well.
So not only did you do multi-view, obviously you've touched upon doing UHD, HDR, and also adding that HEVC tiled encoding. That's a big change.
Huge. I mean, I said it right at the very start that our biggest kind of change in the video pipeline prior to this was probably that jump from 25 to 50 frames a second, which actually I think anyone who was an F1 TV subscriber back when we were 25 frames a second was really thankful that we did that. That small change made such a big difference to the viewing experience. But it was a huge jump, right? We're talking about trying to have the same encoding profile for UHD, HDR with HEVC tile encoding and with epoch locking in place. It's quite a demand to place on something like Media Live.
And finally, it was a massive launch, lots of things going live. How did you prepare for that launch?
A lot of what we did was in the weeks and months leading up to it. You don't just turn up and expect it to be great. We leveraged what is now known as AWS Unified Operations for Media. And that was pre-event. So typically a service that you deploy when you're having a big launch, big change, big event involving media. And the guys there in the engineering and service teams helped us review what Jamie and my architects had specified and deployed as being the best practice and worked through all the different configuration we had, made sure the right alerting was in place, like going through those configurations with a fine-tooth comb, but then being there, not physically with us, but on Slack, through that first race weekend and pretty much every race weekend since then, to a lesser degree, just continuing to provide that level of service and assurance that, yeah, they still care and we're still operating as we expect to.
Cool. I've got to ask this one, sorry. But, for all the fans in the audience for F1, what is actually next for Formula One and F1 TV?
The F1 TV one's easy, right? 2 more onboard cameras next year.
True.
Beyond that, some other features coming. It's a watch this space, but there are some things coming. Next year for Formula One is going to be awesome, right? We've got a big championship decider, but it's the end of an era for the cars that we're seeing. Yep. So actually there's going to be a lot to do, both in our second screen experience and in terms of our live timing setup, in terms of the broadcast, what those new regulations mean, how the teams adopt to them, who's winning that initial charge, some driver changes as well. There's going to be a huge amount going on there and a lot of storytelling to do. It's our job as digital to make that as available and do that storytelling to the fans.
Sure. Be exciting 2026 season then.
Will be.
So just quickly wrapping up, if you want to kind of learn any more about media quality or resiliency, or want to do some further reading on F1 TV Premium or the root cause analysis that Nick presented on, here are the links to their respective blogs. Finally, if you are interested in leveling up your skills in AWS Cloud and AI, I thoroughly recommend you check out AWS Skill Builder, where there are over 1,000 free courses or free resources available for you to use. And with that, from Nick, Dave, and myself, thank you very much for joining our session. Really hope you enjoyed the session. But if you will, just a quick reminder, can you please fill out the survey on the reInvent app, please? But yeah, thank you again once for your time, and I hope you enjoy the rest of reInvent.
Thank you.